All right, we want to solve the following quadratic equations using the quadratic formula. So one thing we already know is we want the quadratic equation in expanded form. So this one is in expanded form or standard form equaling 0. So then we just need to identify the coefficients. Well, in here, the a equals 3, b would be the coefficient on x, which is negative 11, and c would be negative 4. So when I plug these numbers into the quadratic formula, I get x equals, so the first part is just the quadratic formula is structured as a fraction. We have two terms on top, plus or minus the square root, and then we have the bottom factor on the bottom. So as we plug these numbers in, the first term is going to be the opposite of b, and the opposite of b, the opposite of negative 11 is 11. Inside the square root, the first term is b squared. So if I took negative 11 and squared it, I'd get positive 121. And then I got to subtract 4 times a is 3, and times c, which is negative 4. So I'm just going to make this a little bigger. And then the denominator would just be 2 times a, which is 3. All right, so some of the things that we'll be doing when we simplify this, the first thing we're going to simplify is underneath the square root. So if we simplify that, we get 121. The next term would be a negative 4 times negative 4 times 3, or a positive 48. So if I add these two together, I get 169. So I'm just going to rewrite my expression. I get 11 plus or minus the square root, and then now this is 169, and then divided by, and we could just rewrite 6 for the denominator. So the next thing we're going to do is simplify the square root of 169. That is a perfect square, and we actually get 11 plus or minus 13 all over 6. So this generates our answers. We actually get two answers. So we're going to get x equals 11 plus 13 over 6. That's one of our answers, which is 24 over 6, which is 4. And the other answer, x equals 11 minus 13 all over 6, which is a negative 2 over 6, which is negative 1/3. So we still get, in this case, it simplifies out to nice answers. We get 4 and negative 1/3. One thing we'll note about that, and I'll just make a note of this, is that when we have a perfect square into the square root, we basically can use the fact that this quadratic equation 3x squared minus 11x minus 4 actually could be factored if we wanted to. We could factor this to 3x plus 1 and x minus 4. And we could use factoring to solve this problem. So if you notice, the answers would be 4 and negative 1/3. All right, let's go to the next problem. For this one, a couple of things. First of all, we have a quadratic, but it's not set equal to 0, and I have these fractions. So the first thing I'm going to do is clear fractions. I don't want to work with fractions in the quadratic formula. So I'm going to multiply both sides, in this case, by 4. And I'm going to end up with 4x squared equaling, so when I multiply by 4, the 2 cancels, leaving just 2x. When I distribute the 4 to this term, the 4's cancel, leaving just plus 1. So now I'll set this equal to 0 by subtracting from both sides the terms negative 2x and negative 1. So from both sides, that would leave me with a 4x squared minus 2x minus 1 equaling 0. So now I have expanded form equaling 0. There is no more fractions, and so we can use these coefficients. A is 4, b is negative 2, and c is negative 1 in our quadratic formula. So again, to start our quadratic formula, x equals, and then we have a fraction plus or minus the square root, and just plugging in for the first term, it's the opposite of b. So the opposite of b would be positive 2. Inside the square root, the first term is b squared, so negative 2 squared is 4. And then I'm going to subtract 4 times a, which is 4, times c, which is negative 1. And that's all over 2 times a, which is 4. So again, we'll start simplifying inside the square root first. So we have a 4, and then the second term, negative 4 times negative 1 times 4 is a positive 16. So this would reduce to 20. So our formula would be a 2 plus or minus the square root of 20, and that's all over 8. So the next thing we'll ask is, can we simplify the square root of 20? So the square root of 20 is the same as the square root of 4 times the square root of 5. So we can rewrite this again as x equals 2 plus or minus 2 square root of 5, and then that's all over 8. So we actually have a way to show this, we have our answer. One of the things we could do, I'm just making this 8 a little nicer, is distribute these terms and show that we have two answers, 2 over 8, and then plus or minus 2 square root of 5 over 8. And we could simplify those so that we get, for the first one, we can cancel the 2 and the 8, leaving 1/4. So this would be the same as 1/4. And then plus or minus, and we can cancel the 2's as factors here, leaving the square root of 5 over 4. So we get our two answers. And when we're done with these answers, I just want us to realize that we get two numbers, and I'm just going to bring this back up here because I have room. But the 1/4 plus square root of 5 over 4, we could approximate, if we plug this in our calculator, we can approximate that to 0.809. And the other answer, 1/4 minus the square root of 5 over 4, would approximate to negative 0.309. So again, we can approximate our answers as long as giving the exact answer. So here's our exact answers, and here's our approximate answers.